creating arrays in JavaScript is pretty basic stuff, but there are actually a couple of gotchas and interesting things that I learned much later in my journey with JavaScript than you might think, and I want to share those with you today. Let's start with something very basic, creating an array and populating it. Obviously, I think we've all created an array literal like this, and then maybe used a basic for loop to put some values into that array. You'll see that we pretty much get exactly what you would expect. We get an array that we've populated. If we don't use the for loop and we just create an empty array like this, we do get an empty array. There's no items in this array. There's no empty slots even in this array. And we'll talk about what that means in just a sec. What we can do as well is, instead of creating an array using the array literal syntax, we can also use the array constructor, and we can pass it a number of arguments if we want. This will kind of reproduce what we just saw. Now you'll notice I'm not using the new keyword here. It's kind of optional with the array constructor, and several constructors actually. We can say new array and we get the exact same output, or we could just say array. And when we run this, we get our array as well. So nothing really too special there. Things get interesting though if we only pass a single argument to the array constructor. Now, if that single argument is not a number, we do get an array with that value. However, the one special case here is if that single argument is a number, we get an array of that length. But notice that this says this array is 5 empty items. Let's also print out array.length here so we can see what we're working with. So this array has a length of 5, but it's what we call a sparse array. That is, it has 5 spots in it, 5 slots, if you will. However, there's nothing in any of those slots. It's a sparse array, meaning it can hold 5 things. Of course, in JavaScript, we could put more than 5 things in an array like this, and it would just lengthen accordingly. However, 5 empty items means it's prepared for 5 items, but there are no items in there. And this is important to know because I've seen many developers do something like this. We create our array of 5, and then we map over that array and we put some value in each one of those spots. So when we map over the array, we would expect this to be now an array of 5 random values. But if we run this, you can see we still have 5 empty items. So what's going on here? Well, these empty slots are treated, I guess, obviously in one of 2 ways. Either they're treated as undefined in some cases, and we'll look at those in a sec, or they're treated as kind of non-existent. We kind of skip over them when we're iterating through the array. And pretty much any function that you can call on an array, map, filter, find, any of those types of methods, will skip over the empty spots of a sparse array. And so when we map, we don't actually map over anything in this case because our array doesn't have any actual values in it. What we could do is actually set some values, and we can see how that map works. So for example, I can set the first item in this list to 2, and maybe since there are 5 elements in it, we can set the last one equal to 3. And if we log this now, you can see we have the first element is 2, we have 3 empty elements, and then we have 3 as the final element. And of course, if we were to map now, and why don't we just map in our console log here, x times 10, right? If we do that, you can see we now get 20, 3 empty items, and 30. And so this is kind of useful for a map. If we have a sparse array that has some numbers in it, we want to be able to operate on those numbers and not get nan as a result in these cases when we're doing some kind of number operation on an undefined value. Now, if we actually do put undefined in one of these spots, you'll see pretty much what you would expect. When we map, we get nan. So we know that if we call many of the array methods that have empty slots in them, we will just skip over those. But what about other cases? For example, what if we use a for loop? And then let's console log the index and then the item at the index. So here we're referencing every value in the array by its index. Well, if we do this, you can see that not only is our actual undefined value considered undefined, but empty slots are considered undefined in this case as well. The same thing would be true if we spread the array. So if we spread our array, then you can see we do have to convert those empty spots to undefined. This kind of makes sense because when you're spreading an array, you want to create a new array where those elements have the same index, or maybe if you're spreading among other elements, they have a consistent index, at least with what their indexes previously were. And so since our value 2 was at index 0 and our value 3 was at index 4, we need to make sure that in our new array, those happen the same way. And so when we spread, we actually get these undefined values here. Interestingly, if you spread an array into an object, what you'll see is we only get the indexes that are actually defined in our initial array, even if they are defined with the value undefined. And so we don't have keys here for 2 or 3. Of course, there are other ways we can loop over an array with a for loop for const I in array. And when we use in to loop over an array, what you'll see is we only get the values that are actually in the array. Now, in this case, in, we're actually getting indexes, right? And so we can do array at I again, and you can see we're actually getting those 3 values that we have actually put into the array. If we do of, the kind of newer, not so new at this point, but the newer syntax for iterating, this is iterating over the array as an iterable. It's kind of the same idea as spreading. And so what we should see here is we get the values, of course, instead of the index, we get 2, undefined, 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 and 3. So those are some of the interesting things that we can do with sparse arrays. But if we go back to our initial example, we have an array, we want to initialize an array with 5 elements, but we want it to have some value at each one of those spots. The common way that I see people try to do this is with fill. So maybe we can fill these all with the number 1. And this appears to work, right? We have an array of 5 ones, and that's great. And when you have a primitive value like that, that works. That's great. However, the trap I see a lot of people falling into is when you're putting a object that you could reference. So like an array or an object. Let's use an object in our case. So if we fill this with an object, of course, initially this looks fine. This is exactly what we would expect. However, if we were to index into that array at the first index, and let's add a name, you can probably see where I'm going with this. We've actually inserted the very same object, a reference to the same object, into all 5 of the spots in this array. And that's probably not what we intended to do. Now, this might seem unintuitive, but remember, fill just takes a single value here and puts that value into every spot in the array. So it's not really that different than if we were to create an object as a variable out here. Let's actually assign name on object itself. This maybe gives a better intuition for what is actually going on here. As you can see, it's the exact same situation. We have the very same object in every spot in this array. So if you want to create an array of 5 objects, what's the right way to do it? One of the nice things about fill that we can see here is fill is one of these objects that is actually operating on a sparse array. We have an array of 5 here. It's a sparse array, and we can fill that sparse array with those values. So one thing we could do is just fill it with some other value, for example, 0, and then we can map. We could ignore the value that we get here. We don't care about this 0, but now we can put an empty object in there. And then if we were to add a name to the first object in this array, what we'll see is only the first array has a name. The other 4 objects are also unique, and so they do not have the name that we gave to the first element in this array. Now, we've been using the array constructor to create this array in all of these cases, but there's a static method that we can use as well, which is array.from. Of course, we're not using TypeScript here, but we still could take a quick look at the type that we would get in TypeScript for array.from. And notice that it can take an iterable, which kind of makes sense, but it can also take something called an array-like. An array-like is an object that has a length and then can have numbered keys or indexes with values at those indexes. And so this is something that can kind of look like an array. One way to do this would be to create an array with a length of 5 like this. Now, if we do this, notice we don't have any keys for numbered indexes. And so if on this object we try and get, object at 0 or at 1 or at 2, well, those values will be undefined because this is JavaScript, and when the key doesn't exist, the value is undefined. And so this is essentially the same thing as having 0 undefined, 1 undefined, etc. Let's start with just length of 5. And if we log that, you can see we have not a sparse array, we have an array with 5 undefined values in it. So with that in case, we could actually do a map like we have tried to do before. We can say math.random, and we get 5 random values in this array. One interesting thing we could do here is, let's say we put a value 1 at spot 0. Let's say we put a value 2 at spot 1. Maybe we have that value coming through in the map here. And then we either use I, or if I doesn't exist, we use math.random to fill in the blanks. And so now you can see we have 1, 2, and then we have these random values filling in the blanks. And so this is kind of an interesting pattern. This is so useful, in fact, that from actually has a second signature that takes both our array-like object as the first argument, and then it takes a mapping function as the second argument. So we can just remove that call in the middle there. So we have 2 arguments to from now, our array-like and our mapper, then when we log this, you can see we get the same result. The thing that a lot of engineers that I talk to try and do is create a two-dimensional array using fill. And that really doesn't work, as we've seen. You get the same array in every spot. To create a two-dimensional array, this is probably your best syntax. We can do array from. I mean, maybe if we're just going to talk about like literal characters, we could do something like this. And this is actually fewer characters. Instead of creating this object literal with a length of 5, you could create just a sparse array, which still has a length of 5, and then map over it and insert that. Let's actually validate that I'm right about this. We can say at 0 equals 1. And if we go ahead and run that, you can see now we have a two-dimensional array with 1 only in that first spot. Whereas if instead we did array 5 fill with an empty array, and then we insert that, we of course have 1 in every array. This was a quick back to the basics look at how we can create arrays in JavaScript. If you like these more nuts and bolts style videos, let me know and I'd be interested in making more of them. Thank you guys so much for watching, and I will see you in the next one.